Page 174, Lesson 3.6 is on simple interest problems. When we're talking about interest, there's different meanings of the word. Like it could be I'm interested in something. But in this case, the interest we're talking about has to do with money. And this could be good or bad, just depending on which side of it we're on. So one case could be that right now you possibly have money in the bank that you've been saving up. And so if you have money in the bank, then it may not amount to too much, but you're probably getting at least a little bit of interest on that money. So interest is like, it's kind of like money that is being paid for allowing somebody to borrow your money. And you may not really think of it as they're borrowing your money. You're allowed to take your money out of the bank at any time, but it's just kind of how it works. So that the bank, has people that are saving the money up, and then they're able to loan money to people that buy houses or cars or things that they may not be able to have afford to pay it all at the same time. So if you have money in the bank, the interest could be a good thing for you right now. It means you're getting paid for letting them borrow your money, so to speak. So the formula we're going to be using for simple interest is I equals PRT. I stands for the interest, which is the money that they're giving you. P stands for the principal. It's spelled the same as like the principal of your school, but principal in this case is like I've got here. It's the amount of money that's either borrowed or invested. So either we're borrowing money, and this is how much we're borrowing, or it's how much we're investing. Or, investing, it could just be how much money we have in our savings account, whatever. R is the interest rate as a decimal. So it's going to be, let's say 5% interest would be 0.05 as a decimal. And then T is the time in years. We've got to make sure we have the time in years when we work this out. Okay, so this is going to be the formula that we're going to be working with. As you can see, there are 4 variables in this formula. What's going to happen is they are going to tell us the values of 3 out of the 4 variables, and then we're going to solve for the other variable. So if you look at example 1, Victoria opens a savings account with a deposit of $300. So that's going to be the principal. She will earn a 1.6% simple interest each year on her money. How much interest will she earn over 5 years, assuming she does not add or take out any money? Okay, so the question is, how much interest is she going to earn? Okay, so they mentioned some things over here. Interest that is applied to the initial amount only is called simple interest. In reality, there's a thing called compound interest, which is what really happens. But this at least gives you the idea of how interest works, and this is not too far off from what happens with compound interest. So the initial amount is the principal. We kind of already mentioned. Okay, so I don't know why the book is doing this, but I'm just going to use that formula that we talked about. So I'm going to do this a little differently than the book. I'm going to say I equals PRT. And on this problem, the principal is the amount of money that she invested, which is $300. The interest rate as a decimal is it was 1.6%. So if you move the decimal over 2 spots, that would be 0.016. And then the time was 5 years. Okay, so this is kind of our easiest case, is when we find the interest, because the I is by itself. And so all we have to do is multiply these numbers together, and that will tell us our answer. So you can see, if you multiply this out, you should get $24, which is the same answer that the book has. What the book did is they said, let's take and find what 1.6% of 300 is, which is $4.80. That would be for 1 year, and then let's multiply that by 5 years. Okay, and like I said, for simple interest, that's what happens. Compound interest, if you're curious, basically what happens is when you get interest, it gets added to your principal, so that the next time your interest is figured, you just always have a higher principal amount that you have, that the interest is being earned off of. One of the things they might ask you for on the problems is the account balance. If you're asked what is the account balance, that would be the principal plus the interest. It's kind of like, how much money do you have now after the interest gets added is your account balance. Okay. So if you look at the try it, Victoria has another account at the bank, pays 2.5% simple interest. How much interest will she earn in 8 years? An initial deposit of $250, assuming she neither adds to nor withdraws from her account. Okay, so they talk about underneath here 2.5% expressed as a decimal. So 2.5, a half is the same as 0.5. So it's 2.5%. I know that has a decimal point in it, but that's not the percent written as a decimal. We have to move the decimal over 2 spots to the left, which would be 0.025. Or if you want, you can say 0.025, just so we make sure we see the decimal point there. And again, the book is finding the interest for 1 year. I'm just going to use the formula again. That's how I was taught how to do these problems. If you want to find it for 1 year and then multiply it, that's fine. So $250 was the principal. The interest rate as a decimal is 25 thousandths, and then the time is 8 years. So once again, we can just multiply those together, and that should be $50 interest. So this problem didn't ask for it, but if you were asked what the account balance is, okay, this is a if, it's not actually happening here, but if you were asked the account balance, you would take 250 plus 50, which would be $300. So with the interest added on, you would now have $300. Example 2, Maya's older sister got a loan to buy a used car for $3,400. What is the interest rate on the loan? So if you look at the information here, you can see that it's $8.50 interest. They told us in the problem that it was $3,400. And we're going to assume, they should have told us this, but it said $8.50 interest. We're going to assume that that's for 1 year. Okay, they should have told us that for sure, but anyway, so the interest Okay, so first of all, sorry, before we use our formula here, it said $8.50 interest every month. So in a year, like the book did, we would multiply that by 12, which tells us we have $102 that we're going to pay in interest over the year. Okay, so $102 in interest. And then we can substitute that into the equation. That goes in place of I because that's the interest. The principal, which is in this case the amount that she's borrowing, is $3,400. The interest rate is what we're trying to find, and then we're going to assume that the time is 1 year. So on this problem, you could multiply over on the right side. All of those are being multiplied together. So commutative property says we can change the order. So we could do 3,400 times 1, which is 3,400. And then to solve for r, they're multiplying, so we could divide by 3,400. And you would get 3/100. That's as a decimal, so we're going to change it to a percent. Move your decimal 2 spots to the right, and that tells us that the interest rate is 3%. If you look at the try it, another company will lend Maya's older sister $4,000. Every month she will pay $11.88 in interest. What is the interest rate rounded to the nearest 1/10 of a percent for 1 year? So this is very similar to the problem we just worked out. It's really identical other than the numbers being different. So $11.88 per month. If we multiply that by 12, is $142.56 is the interest. So we can substitute that in. That's the interest. The principal is the $4,000. The rate is what we're trying to find, and the time is 1 year. Based off of how the problem was worded, I'm thinking maybe this isn't going to come out very nicely, but we'll see what happens. So over on the right side of the equation, once again, these are all being multiplied, so we can change the order. We can multiply 4,000 times 1, which is 4,000. And then to solve for r, they're multiplying, so we need to divide by 4,000. When you divide by 4,000, you should get 0.03564. So it says rounded to the nearest 1/10 of a percent. What we have to do first is move your decimal. It's a decimal form right now. We're changing it to a percent. So that tells us it would be 3.564%. Now that it's a percent, now we can round to the nearest 1/10. So it's going to be either 3.5% or 3.6%. After the 5, we have a 6. So since that's 5 or higher, we're going to round it up. So this is going to go to 3.6% to the nearest 1/10. Look at example 3. Jake opened a savings account that earns 1.5% interest. Jake estimates that, assuming he neither adds or withdraws from his account, he will earn $240 in interest after 10 years. Okay, and here's keywords. Jake estimates that. Okay. So how much did Jake deposit when he opened the account? All right, and it looks like we're just going to trust his numbers here exactly. So if he's going to earn $240 in interest, once again, I'm going to go my own direction on this problem and use that formula. So by using the formula, we can just say our interest is $240. The question is, how much did he deposit? So in this case, we're trying to find the principal. The interest rate is 1.5%. So if you move your decimal over 2 spots, that would be 15 thousandths. And the time is 10 years. Okay, so I think, to me anyway, and maybe it's just because this is how I learned to do these problems, there's more consistency with this because we're always using the same equation and we're not having to think about, oh, is this 10 years, is this 1 year? It just all goes into the same equation regardless. These can be multiplied to simplify the right side of the equation, which would be multiplying by 10 just moves our decimal over 1 spot, would be 15 hundredths. And then they're multiplying, so we can divide by 15 hundredths. And when you divide, we're dividing by a number that's less than 1, so this is going to make this a bigger number, and it's going to be $1,600. Okay, if you'll notice, we kind of did this entirely different than what the book did, but we got the same answer. So $1,600 is what he deposited. If you had time and you wanted to check this, it's a pretty quick check. We could just say the principal is $1,600. So if you do 1,600 times 0.015 times 10, and you should get $240. So if you look at the try it, Caitlin's older brother borrowed money for school. He took out a loan that charges 6% simple interest. He will end up paying $720 in interest after 6 years. And the question is, how much did Caitlin's brother borrow? Okay, so we're trying to find out how much he borrowed, which is going to be the principal again. We're going to start with our formula. $720 interest. We don't know what the principal is. 6% as a decimal. Just move your decimal over 2 spots to the left, would be 6 hundredths. And the time is 6 years. So to solve this, let's simplify over on the right side. If you multiply those together, would be 36 hundredths. And then they're multiplying, so we can divide by 36 hundredths. Gets those to cancel, and that would be $2,000. So this gives you a little bit of an idea of how to solve simple interest problems. We will work some more problems on another video. Have a good day.